Hey guys, welcome back to 12.3. In this video we're talking about the determinant of a 2x2 and 3x3 matrices. So the determinant of a 2x2, so first of all, what is a determinant? A determinant is a special value that we can find for matrices that only for square matrices, so 2x2, 3x3, etc. That help us do things like find the inverse and tell us different properties about the matrix. So they're useful values, so we're going to learn how to find them. So for a 2x2 matrix, it's pretty straightforward. The determinant is this diagonal minus this diagonal. So if I had, say, 1, 2, 3, 4, that was my matrix. Then my determinant, which we write as det and then the letter of the matrix. So let's just say this is matrix A. That would be 1 times 4, that diagonal here, minus 2 times 3, right? This diagonal here. So that's 4 minus 6, negative 2. So the determinant of this matrix would be negative 2. So again, you just multiply this diagonal minus multiply this diagonal. Okay, so let's look at what we would get for a 3x3 matrix, because that's a little bit more complicated. So for 3x3, so say, I'm being unimaginative, but here we go. Say this is my matrix. I'm going to write out the first 2 columns again. 1, 4, 7, 2, 5, 8. So I'm going to write out the first column again, and I'm going to use that to help me find my matrix. So I'm going to multiply this diagonal first. So just like we did diagonals, we're going to be doing diagonals here. They're just going to be more of them. So this diagonal first, so I have 1 times 5 times 9, which is 45. So determinant of this thing is what we're finding. So 45, right? 1 times 5 times 9. And then I'm going to add to that the diagonal, what you get when you multiply this diagonal. So 6 times 7 is 42, times 2 is 84, so plus 84. So I'm still adding when I'm doing this diagonal, and then I'm going to do the third diagonal, which is, so this is why I rewrote those second 2 rows, so that I could just get the diagonal instead of having to say, okay, this, and then you go over here and get these 2, right? That's confusing. So we just rewrite them, and then it's just a diagonal. So we have 8 times 4, which is 32, times 3, which is 96. So plus 96. Okay, so that's this direction. Those are the positive ones, and now we're going to have negative ones. So we're going to do the opposite diagonals, right? We're going to do diagonals in this direction. You can think about it as starting from this corner, or you can, yeah, I mean, it doesn't really matter as long as it's this diagonal. So we're gonna multiply the diagonal. So 7 times 5 is 35, times 3 is 105. Yeah, 105. So now we're going to be subtracting. So when we're doing diagonals in this direction, we're adding. In this direction, we're subtracting. So this is going to be minus 105. Okay, so then we're going to do the same thing with this diagonal. So this diagonal, and we're going in this direction, so that's subtracting again. So 8 times 6 times 1 is, what, 48? So minus 48. And then one last diagonal. This one, multiplying them all together. So 2 times 4 is 8, times 9 is 72. So subtracting here, 72. So that's how you find the determinant of a 3 by 3 matrix. So the setup, again, you're just rewriting those first two columns, and then you're taking these 3 diagonals. So you're multiplying the diagonal and then adding it for the 3 in this direction, and then subtracting for the 3 in this direction. And then I'm going to put that into a calculator. So 45 plus 84 plus 96 minus 105 minus 48 minus 72 equals 0. The determinant of this is 0, which is kind of nice because I needed to talk about what happens when your determinant is 0. So that's fortunate. When your determinant is 0, that means that this matrix does not have an inverse. So, like I said, we can use the determinant to help us find our inverse. If your determinant is 0, it means that your matrix does not have an inverse. So that's interesting. So yeah, another thing to mention is that not all matrices have inverses. And so that's how we can figure out whether or not it's going to have an inverse. If the determinant is 0, then the matrix has no inverse. So this has been determinants of matrices. I'm going to do more examples of these, but I figured this video is probably long enough by now. So I'm going to stop here, and then in the next video, I'll do some examples of finding determinants. Hopefully this helps, and I'll see you in the next video.